bounded sets. A non-empty set E, subset of the set of real numbers, is said to be bounded if there exists a positive number m such that for all x in E, the absolute value of x is less than or equal to m. Equivalently, we can say that x lies between minus m and plus m for all x in E. A non-empty set E is said to be bounded above if there exists a number m star such that x is less than m star for all x in E. Now let's look at what it means for a set to be bounded below. A non-empty set E is said to be bounded below if there exists a number n star such that x is greater than n star for all x in E. A non-empty set E is bounded if it is bounded both above and below. If there exists an x0 in E such that no matter how big m is, the absolute value of x0 is greater than m, we say that E is unbounded. Now, we're going to look at a few examples of bounded sets. The set of real numbers is obviously not bounded, but the set of positive real numbers is bounded below, and the set of negative real numbers is bounded above. In the set of positive real numbers, x is greater than 0, while in the set of negative real numbers, x is less than 0. The second example is the closed set and the open set. These two sets are examples of bounded sets for finite A and B. Now let's take note of the following. If a set is bounded above by m star, then m star is called the upper bound of that set. If a set is bounded below by n star, then n star is called the lower bound of that set. When an upper bound of a set is obtained, then any number that is bigger than or equal to that upper bound is also an upper bound of that set. What do I mean? Let's say that the upper bound is m star and the number bigger than or equal to the upper bound is m0. Then it means that x is less than or equal to m star and m star is less than or equal to m0 for all x in that set. And this implies that x is less than or equal to m0 for all x in that set. Similarly, any number that is smaller than or equal to a lower bound of a set is also a lower bound of that set. What do I mean by that? This simply means that if n star is a lower bound of a set and n0 is any number smaller than or equal to the lower bound, then x is greater than or equal to n star and n star is greater than or equal to n0. This implies that n0 is less than or equal to x for all x in E. So when a lower bound of a set is obtained, then there are infinitely many other lower bounds of that set. Similarly for upper bounds. This is the end of this video. Having learnt about bounded sets, we can now move on to the concepts of infimum and supremum in our next video. Make sure you don't miss our next video. See you guys. Thank you for watching.